the experiment of a packed bed reactor. Now, this experiment is, as you can see, this is our packed bed reactor, and throughout this experiment we will be studying the residence time distribution along the packed bed reactor. Now, the residence time distribution of a reaction is basically a characteristic of the mixing that occurs in the reactor. For this reactor, there is no axial mixing such as the CSTR where you have something to steer it. Instead, there are these little beads throughout the reactor which provide surface area for more mixing and therefore making a distinctive residence time distribution, which will be studied experimentally by using a tracer. In this case, we'll be having sodium chloride, and we will inject it to see how the mixing occurs within the reactor. Now, for us to understand and to see how it occurs, we'll be using conductivity as our parameter to detect the presence of the ions within the experiment.
Yeah, for this experiment, we want to study the effect of residence time distribution, which we call the RTD, based on 4 conditions. The first condition is the step change input for current flow, and for the second one is for the counter current flow. The step change input is we constantly pump in the sodium chloride solution throughout the experiment, and the difference is the co-current flow and the counter current flow. The co-current flow is we flow the air and the water in the same direction, while the counter current flow is we flow the air and the water flow in the different direction. Yeah, and for the third condition and the fourth condition, we use the pulse input for co-current and counter current flow as well. So the pulse input is we pump in the disturbance, which is our sodium chloride solution, for only 2 minutes. Then after that, we off the pump too, and we continue this experiment until we got the constant conductivity.
For this particular experiment, we will be using packed bed reactor. So we will fill the reactor with ratchet rings with 1500 ml high. Then we will pump in the air and water by switching on the pump 1. Later, we will be injecting our tracer, which is sodium chloride, by switching on the pump 2. And we will observe our result, which is the conductivity, by using the software in the PC.
Good evening, Dr. KJ. Today, I'll be explaining about the industrial applications of the packed bed reactors. Packed bed reactors are usually used to improve the contact between 2 phases of chemicals, like the liquid and vapor. Chemical industries are one of the industries where packed bed reactors are used. It is one of the most commonly used reactors in the chemical industries, mainly in the heterogeneous catalytic process. This is due to the high conversion rate per catalyst weight compared to other catalytic reactors. Furthermore, the distillation industry is one of the industries where the packed bed reactors are used. A distillation industry like the petrochemical industry, it is used to enhance the contact between vapor and liquid instead of tray packing. Thank you.